All right, the last part is dividing complex numbers, which tends to be the most difficult because you've never divided expressions before, or you've most likely never divided expressions before. So the first thing we need to talk about is what is called a complex conjugate. Every complex number has a complex conjugate. It's really simple. It's another complex number with the same real number, but opposite imaginary number. So it's really simple. Find the complex conjugate of the following. You can keep the same real, but opposite imaginary. So the complex conjugate would be 3 minus 2i. Negative 4 plus 5i. 7 plus 2i. You're just switching the sign in front of the imaginary part. Number 4 is just 8. The complex conjugate is still 8. 3 plus I. Number 6 only has the imaginary part, so we're going to just make that negative 5i. You're just switching the sign in front of your imaginary part. That is all the complex conjugate is. We're going to use that. That's beneficial. The product, multiplication, the product of a complex number and its complex conjugate is a real number without an imaginary part. So we're going to look at the examples here. I'm going to show you how that works. We're going to find the complex conjugate, and then we're going to multiply the complex number and its conjugate. So we're going to take 4 plus I times 4 minus I, right? Just change that sign. Now we're going to multiply, just like we did in the last lesson, and I'm going to show you how we get this real part and no imaginary. 4 times 4 is 16. 4 times negative I is negative 4i. I times 4 is plus 4i. And I times negative I is negative I squared. Okay? 16 is 16. Negative 4i plus 4i is 0, so those are gone. And negative I squared, well, I squared is negative 1, so it's negative 1, which then is 16 plus 1, which is 17, which is a real number. Second example, we're going to use its complex conjugate is 2 plus 5i. 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is negative 10i. And negative 5i times negative 5i is, negative 5i times positive 5i is negative 25i. So 4 is 4. Your like terms in the middle, 10 minus 10 is 0. That's gone. Then this is minus 25. Oh, hold on. Catching myself. Get a squared on there. 5i times 5i is 25i squared. And then this is negative 25 times I squared, which is negative 1. So 4 minus 25 times negative 1, which is 4 plus 25, which is 29. Okay. And this one is going to be a pretty simple one. The complex conjugate of 7i is negative 7i. 7 times negative 7 is negative 49. I times I is I squared. But I squared is negative 1. And that makes that positive 49. Okay. So there is a way, though, to get these answers without doing all of that work. There's a pattern here. What is 4 squared? 16. And these two negatives are going to turn into a positive. And in front of this I is a 1. What is 1 squared? 1. The A here is 2. What is 2 squared? 4. Plus, what is that 5 squared? 25. In this one, it's like I have 0 plus 7i. 0 squared is 0, plus 7 squared is 49. So the product of a complex number and its conjugate is always going to be a squared plus b squared. It's always going to end up as a positive. So similar to when you did your graphing in your absolute value and you did a squared plus b squared and then you wanted to equal c squared, it's kind of the same, except this time you're not doing the equal c squared part. You're not going to take the square root. It's just that is your answer. Take your a value and square it, plus take your b value and square it. All right. So now let's talk about how that's going to be helpful for dividing complex numbers. When we divide complex numbers, we need to start by multiplying the fraction that you have by a weird looking 1. What I mean by that is I can't multiply by 1 exactly, but I need to multiply by 1 because if you multiply by 1, it doesn't change anything. But I don't want to multiply by the number 1. I want to multiply a fraction of something over itself, because something divided by itself is 1. And that something is the complex conjugate of the denominator over the complex conjugate of the denominator. So then we're going to have a fraction times a fraction. And when you do that, you multiply your two numerators together and your two denominators together, and then simplify. And as we do this, we're going to use our multiplication rules from the last lesson. And you're going to remember to reduce your real and imaginary parts so that your final answer is in the form a plus bi. And a and b, or either of them, are allowed to be fractions. But you shouldn't leave it as one big fraction. You're going to separate and simplify your fractions if possible. So let's go through these so this can make a little more sense. To do this division, you are going to multiply by a fraction, and that fraction needs to be, looking at your denominator, the complex conjugate. So since this is 6i, the complex conjugate is negative 6i. And I need to make it that same fraction because something divided by itself is 1. And if you multiply by 1, you're not actually changing anything. Algebraically, mathematically, you're keeping it in a different format, but the same thing. So now we're going to multiply across the top and then across the bottom. Negative 5 times negative 6 is positive 30. I times I is I squared. Now your denominator. This is where this fact comes in handy. The product of a number and its complex conjugate is a squared plus b squared. In this case, a is 0 and b is 6. So now we're going to simplify. 30 is 30, but I squared is times negative 1. 0, oops, and this should have a squared on it. 0 squared is 0, plus 6 squared is 36. 0 plus 36 is 36. 30 times negative 1 is negative 30 over 36. And then you're going to reduce your fraction, which your calculator can do that for you. If you don't know how to, you don't do a division, you enter in as a fraction. And then if you just hit enter, it'll reduce it for you. Or you can remember that to reduce fractions, you're looking for something that can divide both of them. They can both be divided by 6. So negative 30 divided by 5, negative 30 divided by 6 is 5. And 36 divided by 6 is 6. Keep a negative. Negative 5 over 6 is the answer to this first problem. Now, you're going to look at me and you're going to say, Mrs. Mullen, couldn't I have just canceled out the i's there? Yes, in this problem you could have. But not in this problem. and not in this problem, and not in this problem. So although, yes, you could have done that here, and as you get to your real practice, you can do that, I wanted to show you an example. So you have 4 examples of how to go all the way through. So example number 2, we're going to start by making a fraction that we're going to multiply by. It needs to be the complex conjugate of your denominator, which would be negative 3i. Okay, now this one, I need to distribute that negative 3i to both of those terms. 4 times negative 3i is negative 12i. I times negative 3i is negative 3i squared. And in your denominator, a squared plus b squared. Negative 12i is negative 12i. But negative 3i squared is negative 3 times negative 1. I squared is negative 1. The 0 squared is 0, plus 3 squared is 9. Negative 12i is still negative 12i. Negative 3 times negative 1 is now positive 3 divided by 9. Now, your numerator is not in the right order, so we're going to flip that around. 3 minus 12i over 9. And we are still not in the form a plus bi because I have this big fraction. So we're going to do 3 over 9 minus 12i over 9. And then check to see if we can reduce. So 3 over 9 would reduce to 1/3 minus 12 over 9 can also reduce to 4 over 3i. Okay. Example 3. We're going to get a little bit more complicated as we go. Timesing it by our fraction. Complex conjugate of your denominator is 3 plus 5i. So once again, we're going to distribute, but this time it's that 2i that gets distributed since it's a one term. 2i times 3i is 6i. 2i times 5i is 10i squared. Your denominator is a squared plus b squared. Now you're going to say, Mrs. Mullins, shouldn't I be taking negative 5 and squaring it? Sure. What's 5 squared? 25. What's negative 5 squared? 25. So you don't really need the negative there because you're going to square it, turn it into a positive. 6i is 6i, but then plus 10i squared is 10 times negative 1. 3 squared is 9, plus 5 squared is 25. In the top, you can then simplify. So 6i minus 10, and then you can simplify your denominator. 9 plus 25 is 34. Now your numerators are in the wrong order, and you also could split it up into its 2 fractions. So I can do negative 10 over 34 plus 6 over 34i. And then you can see if your fractions can reduce, which they can, would be negative 5 over 17. Nope, no I on that one. Negative 5 over 17 plus 6 over 34 reduces to 3 over 17i. Once again, your calculators can, oops, hold on, see that? Your calculators can reduce these fractions. If you enter them in as a fraction and then just hit enter, it would reduce it for you. Let me know if you need to see how that works. All right, your last problem. Timesing it by the complex conjugate of the denominator is 1 minus 3i. Now, here is where in your numerator you are going to have to FOIL. 4 times 1 is 4. 4 times negative 3i is negative 12i. Negative 7i times 1 is negative 7i. And negative 7i times negative 3i is a positive 21i squared. All divided by a squared plus b squared. Now, if you don't memorize this, that's fine. Just keep doing your FOIL in the bottom also. You'll get the same answer just with more steps. My way is faster and simpler, but if it's harder for you to memorize, just do your FOIL in the denominator also. Now our numerator, 4 is 4, but I have these like terms. Negative 12 minus 7 would give you negative or minus 19i, plus 21 times negative 1, because that I squared, divided by 1, plus 9, right? 1 squared is 1, 3 squared is 9. That is then 4 minus 19i minus 21, all divided by 10. I have like terms 4 minus 21, which is negative 17, minus 19i, all divided by 10. I am in the correct order, but I do need to split those up to be negative 17 over 10, minus 19 over 10i. And those fractions cannot reduce. There is your final answer.